Hello everyone. To know about more continuous probability distribution, this time we are going to discuss about exponential probability distribution. Many of you already know about the exponential curve. Let's find out what is exponential probability distribution. Exponential probability distribution mainly used to model the amount of time until some specific event occurs. It also suggests that the length of time between two occurrences of an event. Basically, it provides us the answer of few questions. If you ask some questions something like that, what is the probability that some event will occur within next t hours or days, or what is the probability that some event will occur between t1 hours and t2 hours, or what is the probability that the event will make more than t1 hours to perform. In short, the random variable x, actually the time for occurring an event. Generally, the exponential distribution is heavily used to find out the probability of those kind of variable where we need to find their lifetime or life expectancy or the survival time. As you see, as the time passes, most of the objects' life expectancy decreases. You can consider something like electronic component. As the number of days increases, their life expectancy decreases. For those kind of variables or random variables, we can use exponential distribution. Let's take an example of 100 produced light bulbs. We have a history of that bulbs. Those are perfectly alright initially. But as the day increases, few of them got fused. Like after first day, one light got fused. After several days passed, we can say after 10 days, 3 more lights got fused. After 20 days, 5 more lights got fused. And after a few months, 5 more lights got fused. So, what you can observe here, as the time increases, the rate of their lifetime, or you can say that as number of days increases, the lifetime of light bulb decreases. And to find out that probability, we can use the exponential distribution. Here is few more examples. If you set these random variables like x1, time to repair a machine, lifetime of an electronic component, and time until a certain event occurs. As we say, our previous example, as day passes, the number of survival probability of non-defective bulb reduced. So we can say it can be present as exponential distributed random variable, the lifetime of a bulb, and we can calculate the probability using this probability density function for given or defined in exponential distribution. So x is a continuous random variable where we have this probability density function, and if you look closely, it has this form, which is lambda e to the power minus lambda x. The range of x, it's a positive range. It always be greater than 0 with no upper limit. And also we have the parameter lambda, which is also a positive quantity with no upper limit. Now, many of you can identify the lambda as a parameter of Poisson distribution. But as you know, Poisson distribution is a discrete probability distribution. So how can it be a parameter for exponential distribution, which has a random variable, a continuous distribution? If you look closely, this definition of Poisson distribution random variable x, you can find out the number of occurrences per unit of time. That means the random variable x in Poisson distribution gives us the number of occurrences per unit of time. And its average or mean is denoted by lambda, which is average number of occurrences per unit of time. But how it could be a parameter for exponential distribution? It's possible because we define here the exponential distribution something like that: amount of time per unit of occurrences. So here x is how much time required to occur an event. In Poisson, we have how many events occur on per unit of time. That's the difference between Poisson distribution and an exponential distribution. You can say it's just the opposite. So that's why the average or the mean of exponential distribution is 1 by lambda, which is defined as the average amount of time per unit of occurrences. So if I repeat again, the Poisson distribution gives us the number of occurrences per unit of time, and the exponential distribution gives us amount of time for per unit of occurrences or per occurrences of an event. So that's why we have an average or mean, or you can say the expected value 1 by lambda for exponential distribution, and the variance is 1 by lambda square. Now, to get more clear idea, let's find out the difference between two probability distribution means. Let's say we have 4 events here that will occur in an hour. So on an average, we can say that 4 events will occur in an hour, and for that reason the lambda equal to 4 events per hour, and this lambda actually comes from Poisson distribution, where the random variable x actually number of events occur per unit of time. Now we need to know how much time requires to occur one event. That means for exponential distribution, the random variable said that the time required to occur an event. So in that case, the lambda is the opposite, which is 1 by lambda, and the time requires 1 by 4 hour per unit on average. That's how you can distinguish very easily that this lambda actually works similar for both Poisson and exponential, but when we use for exponential distribution the parameter or the average value, it becomes 1 by lambda. Now let's find out a problem. Let's solve this problem we have here. The question is here, average time required to repair a machine is 0.5 hours. What is the probability that the next repair will make more than 2 hours? Initially, you need to find out the probability x greater than 2. Now, what is x here? Like any other probability distribution, defining a random variable is the most important thing to solve a probability distribution problem. Here, x is the time required to repair a machine. Now, it is given that average time required to repair a machine is 0.5 hours. So, we can connect this thing with our exponential average or exponential mean parameter. As we know that average amount of time to occur an event. So that's how we have here average time required to repair a machine is 0.5 hours, which similar the definition of mean value of exponential distribution. And we know that the mean of exponential distribution is 1 by lambda. So we can write here 1 by lambda equal to 0.5, from where we can calculate the lambda equal to 2, which makes sense actually, and it's also expected, is that if half an hour requires to repair one machine, then to repair 2 machines it will require 1 hour. So in different angle we can say 2 machines will be repaired by 1 hour or 1 unit. So that's how lambda is defined. Now let's write in a proper way that x follows exponential distribution with lambda or parameter equal to 2, and that's how we can find out the value of lambda. After that, we need to find out the probability that will take more than 2 hours to repair that machine. So this is the density function to find out that probability, and as we know, the range of random variable x is always greater than 0. and it has no upper limit, so we can write that for more than 2 hours the limit should be from 2 up to positive infinitive and then the density function. So from the density function definition of exponential distribution, we can write here lambda e to the power minus lambda x, where lambda is 2. So if you write these things in a proper way, you can have these things. That means probability of x greater than 2 equal to 2 to infinitive lambda e minus lambda x into dx. That's the form we have, 2 into e to the power minus 2x into dx, and after some simple calculation you will get this value, which is actually 0.0183. It's a very small probability, I must say. So you can say that now the probability that the next repair will take more than 2 hours is 0.0183, or in different way we can say there is 1.83% chance that the next pair will repair more than 2 hours. Now if you see these things in a graphical way, you can say you need to find out this probability actually, and this is the area, which is a very less probability, or you can say very small probability, 0.0182 or 1.83 chance, which is very small. And that's how exponential distribution, if you have a continuous random variable which follow the exponential distribution, that's the way you can find out the probability of their lifetime or their survival time, or you can say the life expectancy of that product or objects. Now you can also use some different programming language to find out this kind of probability. Let's see, as we have the lambda equal to 2 and we need to find out probability of x greater than 2 where x less than 2. Now let's calculate this probability and it will give you the same value, 0.01832. That's a very small probability you can find out here, and also it gives you the expected value, that is the half, and the standard deviation 1 by lambda square. So that's the another way you can double check your answer, is it correct or not. It has many options like less than or greater than, whatever you have you can find out. Now if you have a question something like that, that next repair will take less than 2 hours, then what will be the range? The range will be something like that. The upper limit will be 2 and the lower limit must be 0, and that's how ff of x into d of x. So that's how you can also calculate the probability if your question is something less than 2, or if you have a question something greater than 2. There is some other way. If your random variable follows the exponential distribution, you can find out the probability using this expression or this relation also directly, like probability of x less than or equal x. You can use this expression 1 minus e minus lambda x. After calculating the lambda, you will get the exact same result, and for x greater than x, you also can find out e minus lambda x. These are also some expression you can use directly to calculate your probability for your desired problem. So that's all for exponential distribution.